My name's Andrew Brust, and I've been speaking on data topics really since, I guess it's almost 20 years now. I've worked with SQL Server since the first version of it that ran on Windows, which was 4.2. I've written about data and data access and databases going back to the mid-90s as well for a magazine that was once upon a time called Visual Basic Programmer's Journal. And well, I'll tell you some more about myself soon enough. They have forced us to put this at the beginning of our slide decks, which is good, because not only do I forget to silence my own phone even when I'm speaking, but I definitely forget to remind people. So there you go. So here we finally get to a slide about me. I'll just sum it up this way. I've been working with Microsoft and Microsoft technologies for about 20 years. I started with Microsoft technology, I mean, unless you count DOS, I started with Microsoft technology with Visual Basic version 1.0. Before VB, I did a lot of DBase and XBase and FoxBase and FoxPro programming. So data's always been an important thing for me. I'm involved in the community. I help run a couple of user groups in New York City. I run a company called Blue Badge Insights, and our whole business is helping Microsoft partners navigate the water of Microsoft partnership with a little more savvy and a little more help than they'd have otherwise. I also write a column called Redmond Review for Visual Studio Magazine, which, if you didn't know, is the successor to the Visual Basic Programmer's Journal magazine that I mentioned before. And on top of all this, I'm also the guy who writes about big data and related technologies for ZDNet. That's been true for about a year. That has absolutely sort of immersed me in the world of data well beyond Microsoft. I do write about Microsoft once in a while. I wrote about them today to talk about the GeoFlow announcement that was made at our keynote here. But most of what I write about is well beyond the Microsoft fold. So it's interesting to come back. Technically, this isn't a Microsoft conference per se, but it's interesting to sort of come back to a Microsoft audience and try and connect the dots between all these non-Microsoft technologies and how they might fit in with the Microsoft stack, or at least with, I don't know, the approach and the thinking of people who are practitioners with that stack. Just to convince you, though, that I have even more Microsoft street cred, I'm the co-author of this book, and I was the lead author for the SQL Server 2005 edition. There wouldn't have been an R2 2008 or 2012 edition unless somebody else took that post. So I don't know if you know the name Lenny Lobel, but you should. He's a fantastic speaker, great author, and improved the book nicely. Here's what I want to do, and normally I would do this in 75 minutes, but here we try and compress. So I'm going to try in 60 minutes, now 57 remaining, but who's counting, just to talk about some of the motivation behind NoSQL as I see it, then talk about some important concepts that underlie the various kinds of NoSQL databases. There are, roughly speaking, 4 such categories of NoSQL databases. So the meat of this talk is to go through each of the 4 categories, talk about, architecturally how they work, and for 2 of those 4 categories, I'm going to try and fit demos in. So I'm going to try and take you into a demo of HBase. I'm going to try and take you into a demo of MongoDB. Obviously, they're going to be somewhat superficial demos given the time constraints, but my biggest problem with big data and with NoSQL is there's so much written about it that's abstract. And I just can't understand anything unless I can get my hands on it and type some commands in and see what it is. And I tend to think that most people at conferences like this are somewhat the same. It's a natural skepticism, and if you can at least see what's going on, it cuts away some of the intimidating fat around these technologies. So hopefully I'll be able to take you through that, and then we'll finish up with some quick discussions about how things are faring in the market, some discussion about how to kind of provision these various databases, especially in the world of Windows Azure, and some, of course, some takeaways. So first, let's just talk about the why. And I'm going to give you an opinion that I don't really see spouted a lot. So this is just me, I guess. But I always like to take things back to writing desktop applications in the mid-90s with Visual Basic. It's just sort of, I don't know, it's my point of reference. And I would write applications that use databases. Actually, my first ever real article was a cover story on optimizing the JET database engine, which was the access engine that eventually VB adopted. And so I used databases such as they were. But there was always stuff in those applications that I needed to store. User preferences, window positions, color schemes, those sorts of things. Stuff that I wouldn't really think belonged in a database. I suppose it was data, but it needed to be stored somewhere. And given the time frame, I stored that kind of stuff in an ini file. And maybe today we would do the same thing with config files. So think about things, just kind of files and notes and just some loose kind of user profile data. Or keep going, addresses and preferences and, oh, I don't know, documents. We've always had this thing with documents, whether they go in the file system or whether they go in the database. And here, pretend you didn't see that yet. And if I kind of think about that, but then I think about taking one of those desktop applications from the mid-90s and putting them on the internet now and bringing the user population from about 5 to maybe about 5 million, suddenly I still have these very simple data requirements, but I have them at very large scale. And suddenly it's a real workload. And suddenly just throwing stuff in a config file on the file system ain't going to cut it. Now, it's not really what I would think of as a database with normalized design and everything all elegant and rows and columns. It ain't like that. But it's also not just a few pieces of data. It really is data. We need some kind of engine for that if we're facing the public web and the public internet. And by the way, we need it so that the reads and writes of those admittedly simple pieces of data happen very, very quickly, because otherwise the latency is going to kill us. People are impatient in general. People are impatient on the internet. And if you're slow, then they're going to move on to your competitor. So we're going to need stuff to serve those workloads. And as long as we're in the world of the internet now, think of social media, friends and followers. Think of notes. I always think of Evernote, although I read an article that said Evernote actually uses MySQL to store their stuff. They don't use a NoSQL database. But imagine if they did. It kind of seems reasonable. So to me, it's those kinds of scenarios where NoSQL makes sense. Relational databases, in many ways, would be overkill for those kinds of scenarios. And on the other hand, they're really not built to handle that kind of scale. Think of all the features in a relational database that we wouldn't use. And it's funny, I went into the Twitter app for Windows 8 and said it should not put up toast notifications, specifically so that wouldn't happen, but maybe I need to uninstall the app. It's okay, as long as you say nice things, I guess it's okay. So anyway, we need something to deal with the large volume of simple needs. Now, I know and you know that NoSQL databases are already being applied well beyond those scenarios, but to me, those are the canonical scenarios where NoSQL databases make sense. It's this whole idea of web scale. And by the way, there's a very humorous, not appropriate for the workplace video up about two people having a discussion about NoSQL and web scale. Ask me for the link later. And just think about sites, companies like Amazon or Google or Facebook. And as it turns out, a lot of the really important NoSQL databases actually emanate from those companies. LinkedIn is another one. So although these things have their own ecosystems and their own contributors, most of them happen to be open source projects, they all kind of started from companies where relational databases, using those was kind of a square peg round hole proposition. all kinds of features in a relational database that weren't needed, and then just the raw availability to do writes and reads really quickly of really simple things, retrieving things by a single key and just getting everything, not heavy ad hoc query needs. We needed special databases. Those companies needed special databases for that, and in large part, they built them themselves. So if we talk about NoSQL, and like I said, there are 4 broad categories in these databases that we'll get to, but there are some things that tie them all together. First of all, they're non-relational, and actually that would be a much better name for these databases than NoSQL. SQL really has nothing to do with it. For example, Cassandra, which is one of the leading NoSQL databases, has something called CQL, and it looks just like SQL. So this isn't about the query language per se. It's about the data not being relational, and B, very often not following any formal schema, as weird as that sounds. Depending on the type of NoSQL database, it may follow some schema. Other kinds may not follow any. All right. They mostly are open source, although there are some proprietary ones put forth by different cloud providers that we'll talk about. They tend to work in a distributed nature almost by default. So if we think about the big 3 relational databases today, Oracle DB2 SQL Server, I always put SQL Server last to be polite, but I always think of it first. Deploying those in a clustered manner is, it's non-trivial. It's a specialized skill set. But most NoSQL databases are really built to be distributed, and by the way, distributed geographically over the internet without it being a big deal. And if you think about, again, the internet use cases, that makes an awful lot of sense. Most, not all, most NoSQL databases don't enforce consistency, database consistency in the way that relational practitioners would be used to. That's a very euphemistic way of putting it. They're non-transactional. They employ a model called eventual consistency. We'll talk about eventual consistency. I'll give you a use case for eventual consistency that you already use and are comfortable with. You just may not realize it. And as I said before, most of these things are developed for the web scale scenarios at and by big internet companies. So let's talk about the consistency a little bit more. There's this thing in the database world called the CAP theorem. It's one of those things everybody should know, but when I started writing that white paper, honestly, I had to go look it up. And what it says is that there's 3 attributes that databases exhibit, but they can really only be good at 2 of them. So consistency, availability, and partition tolerance. Pick any 2, says the CAP theorem. And NoSQL, in effect, it's sort of like pick any 2 or pick the one that you're going to sacrifice. So NoSQL has picked consistency as the one that it's going to sacrifice. So no ACID guarantees offers that eventual consistency. And I told you I'd give you a scenario where eventual consistency works. And that is the internet domain name server system, right? How many of you have ever kind of managed your own domain name? Maybe done a DNS update here or there, even if it was through, I don't know, GoDaddy's webpage. You don't have to be a real infrastructure jockey to do this. Now, it's better now than it used to be, but when you go to make those updates, let's say to a host record, an A record, and you're changing the IP address that a given name points to, that doesn't propagate throughout the entire internet immediately. You'll have weird situations where some people you know can see that change almost instantaneously, and other people, depending on their ISPs, may still be going to the old server. And it takes a while to propagate out. And that is an eventual consistency model. And it's okay, because it would be a little weird for you to say, well, until the very last DNS in outer Mongolia gets the update, I don't want anyone even downtown in Manhattan to get it. I need that to be atomic. No, you don't. It's actually better for you if it starts rolling out in a phased way. First of all, it means that you're not locking things in some ridiculous global fashion. But second of all, it means people start to get the updates quickly rather than making everybody wait till the last one. So there are going to be situations in data processing where that same kind of tolerance will exist, and the same preference for getting things out to as many people as soon as possible also makes sense. So this slide just speaks to that a little bit. Obviously, if we go to the pedagogical example of debiting one account and crediting another one, we don't want eventual consistency there. That ought to happen atomically, right? The rules of the world don't change here, by the way. If you're doing line of business development based on business processes that are regular, then guess what? Schemas work, atomic consistency works, and we don't have some new rule that says you can throw that out the window. That would just be silly. But if you think about Amazon, right? Because Amazon does different things. They do lots of different things. One of the things they're going to do is deal with supply chain, where if somebody depletes inventory on something, you don't want that inventory update to not be reflected to somebody else who then may go and buy the merchandise. But Amazon also has a product catalog. And by the way, the products in that product catalog probably follow a different schema depending on the type of product it is. And it's probably okay for you to put a new product in the product catalog and have customers in the United States see it before it's even propagated out to some of the servers in Asia Pacific. That's probably okay. So, you do have to challenge your own assumptions. Not that every kind of rule that you're following now is suddenly invalid, but there are going to be scenarios where the rules are legitimately different. So just to make this a little bit visual, and you're going to get different answers, by the way, on relational, which of the two relational really kind of holds true to, but certainly consistency is one of them. I would say partition tolerance is the other. Availability here doesn't really mean high availability. It just means availability, and that reads and writes happen very, very quickly. They're cheap, so that a system can do its read, do its write, and then move on. And so that's important in the NoSQL world. So is partition tolerance, even more important probably than in the relational world. And that's really what we're talking about. You look at these databases, and things that you just took for granted suddenly are gone. So it turns out that a lot of NoSQL databases, and this is changing, by the way. Actually, the whole industry is kind of changing. As these technologies go mainstream and more corporate, they're starting to absorb some of the rigors that they were incredibly missing before. One of those rigors, though, is the ability to index on anything beyond the primary key. And believe it or not, a lot of NoSQL databases can't do that. The whole notion of indexing beyond the primary key is called a secondary index. I mean, who even knew we'd need a special name for that? But we do. Now, you go back to my little desktop application with my user preferences, it's probably okay that I can only index on the primary key. My guess is the primary key would be the user ID, and I want to get everything for that user, so that's fine. And then scale it up to the web scale scenario, and it's still fine. But for us, boy, I mean, things are missing that we wouldn't even think to ask. Is it still there? Another thing to think about is, and this is kind of an extreme example, but HBase that I'm going to show you, HBase uses Hadoop's file system, the Hadoop distributed file system, HDFS. And it turns out that on HDFS, you can't really update files. Let me say that again. You can't really update files. Files are immutable. There are cases where you can append to them, but it's a little bit like a CD-ROM. You write it once, you read it many times, or a DVD-ROM. And what that means is, with HBase, if you've got a lot of writes to make, well, what's it going to do? Actually, what it does is it doesn't make them. It just logs them, and then it will catch up later. And that's, that introduces its own consistency challenges. But it does mean that that write will be a non-blocking operation, mostly because it doesn't happen right away. It's deferred. But man, you gotta think a little differently. Here's another thing. Now, I said it's not really about SQL, and that is true, but the overarching paradigm in the NoSQL world when you're querying is that you don't really query declaratively the way we might be used to. Instead, you actually write imperative code. And it's interesting because remember I said at the beginning of this thing I used to do DBase, XBase, FoxPro programming. Any of you come from that world? Paradox, FoxBase, FoxPro, Clipper 87. Okay, don't raise your hands when I say 87. That's not a fair question. But here's the thing, right? Those were ISAM databases, index sequential access management databases, and tables were files, and files were tables, and we were scanning through them. And yes, we had very fast indexes, so that's different. But this whole notion of kind of declarative query and joins, not so much. Well, this is kind of a return to that world. And I don't know, I mean, of those of you who raised your hands, I don't know if you remember going from the XBase world to the client-server world. But if you remember it and you're honest with yourself, you'll remember that things actually got a lot slower when we moved to the client-server databases. Those bitmap indexes were fast. So there really is, although most of the practitioners with these NoSQL databases, you know, were probably in diapers or not even a twinkle in somebody's eye when we were writing FoxBase code, so they don't realize this. They're going back to something that we had before, and there's probably a good reason for that. Let's, in talking about imperative code, I also have to talk about this thing called MapReduce. Now, MapReduce is a huge, huge, important central concept when you're talking about Hadoop, and I'm not talking about Hadoop. I can talk about Hadoop, but that would be a different session. So this isn't Hadoop's MapReduce, but it is still an approach to dealing with data that is pretty crucial to a lot of NoSQL databases. And the idea is that we look at our data and we deal with it in two passes. And in the first pass, we take the data in whatever semi-structured format it is, and we pre-process it, and we kind of get everything in a key and value format instead. Now, if that seems restrictive, just realize a value can be almost everything, including a structured record of data. So don't worry that a value absolutely has to be a scalar value, a string or a number. It doesn't. But we put things in key and value format, and then in the second pass, the reduce step, we take, in effect, all the values for a given key, and we reduce it down to a single value per key. So oftentimes what we're doing there is aggregating the data. So that's a different way of looking at things. It comes up a lot, not exclusively, but it comes up a lot with NoSQL databases. And if there's time, I'll show you some stuff on CouchDB, but I'll definitely show you some MapReduce code on Mongo. Sharding is another important concept. Sharding is really a fancy word for partitioning. But it's one where the partitions are actually on different physical servers. And if you think back to this idea that most NoSQL databases work in a distributed, kind of clustered form, then you see why sharding would make sense. You get nice parallelism when you partition your database that way. You also get some other kind of interesting benefits. You may get things to the point where, especially in a MapReduce scenario, the data that a given node is working on is the same data that might actually be stored physically, locally. You also get replication. You get fault tolerance because you're going to replicate the data. Any data on a given node should be replicated at least one and probably at least two more times on other nodes. So if one node falls out of a cluster, you're not losing any data. And third of all, the data, it may be geographically distributed in a nice way because most of these NoSQL databases work, their distributed architecture can be geographically distributed. And then the sharding almost works like a content distribution network by putting data close to the edge. So if you have data for Asia Pacific customers on servers that are in Asia Pacific or are in the Asia Pacific region, that might mean less network hops to get to the data that they may need to see. It may not work out that way, by the way, but at least the potential is there. How many of you have worked with SQL Azure, now known as Windows Azure SQL Database? Handful of hands. So there's a feature there called federations. Federations is just sharding. That's what it is. Although with SQL Azure Federations, it's up to you to take a query where you're going to get different data from different shards and pull it all together. Most NoSQL databases wouldn't make you do that. You write a single query and they take care of going to the different shards where the data is located. So that's called a fan-out query. And in the NoSQL world, fan-out is usually just handled by default. With SQL Azure, at least at this point, you have to do that yourself. All right, so that's all the intro, the background. Now we get to talk about the four major categories of NoSQL databases. You may read some taxonomies of NoSQL that tell you there are 5 categories or that there are 3 categories, whatever. Most people agree that these are the 4. The first one, not necessarily the most popular, but the most foundational, is the key value store. What is a key value store? Think of a web cache technology, and you start to get pretty close. Everything is stored with a name and a value. You've done programming, you've worked with associative arrays or dictionaries or collections. That's kind of what this is, but it's a whole database geared around that. So if you've worked, by the way, with Azure Table Storage, that is a key value store NoSQL database. If you've worked with Amazon SimpleDB, same thing. If you've worked with Amazon DynamoDB, same thing. Actually, DynamoDB is the commercialized version of something internal and proprietary to Amazon, just called Dynamo, and that really is the foundational key value store NoSQL database. Here are some logos. I think logos help. It just makes it easier to recognize companies and say, oh, they're over here, they're over there. Besides which, you know, black text, white slide. A little bit of color can be nice. Something the Visual Studio team could take a lesson from, but I digress. Where are we? So, Couchbase, by the way, I'll just point out now, Couchbase is going to show up in 2 different categories for reasons that I will explain. And let's move on. Let's look visually at how the data might be stored. And I'm a little bashful about this example because I made the data that I'm going to show you have a consistent schema, whereas it really needn't and in many cases won't. But look at customers, right? It has a unique ID, a row ID of 101, and then everything else is just a key and a value pair, a key and a value pair, a key and a value pair. Here's another one. I could, though, imagine if I had middle name here that I didn't have in the other one. That's perfectly okay. That's sort of actually the normal use case for loose schema. It's not that everything is different from row to row, completely different, although it could be, okay? But the idea is usually that we have a bunch of columns or keys or rows that are, columns or keys that are the same, and then a couple that differ. And if you work with SQL Server and you think about the kinds of things that you might do with XML columns, that this actually goes after the same kind of functionality. In fact, I mentioned that Azure Table Storage is a key value store or NoSQL database, right? Well, if you work with the developer fabric for Windows Azure, the developer fabric for table storage is implemented by using SQL Express and XML columns. You can actually go into the database and into the XML column and see it for yourself. So that just very nicely proves out the point that you're already working with keys and values. And if you weren't doing it with XML columns, I bet one time in your career you did this wacky thing where you had a table that just stored attributes and values, and then you had a link table. It's especially useful when you have a product catalog, for example. Well, guess what? That was you bending over backwards to deal with a concept that this kind of database deals with natively. So as much as I like to pick on NoSQL databases, there are extreme behaviors that I have exhibited where these would have helped me be a more rational person, I suppose. Here are some related orders, and the reason I put these up here, notice this says 1501, and so does this, right? A nice kind of parent-child relationship that I'm sure you're comfortable with. But there is no key constraint. There is no join. There is no referential integrity. Not in this kind of database, okay? It's up to you to write the code that says, oh, last order 1501, okay, let me go in this table and look for order 1501 if I want to put that parent and child data together. Again, not unlike some of the things we did back in the DBase days. Strange as that may seem. Next category, wide column stores. This is a very important category in the big data world, okay? Especially because this thing called HBase, which I'm going to show you, fits in this category, number one. And number two, tables in HBase are actually files in the Hadoop file system, which means data in HBase can be processed by Hadoop, and the output of a Hadoop job could be an HBase table as well. So HBase and Hadoop can work together very tightly, but it's also important to know that you can use either one independently. A lot of Hadoop stuff is just done on flat files, and a lot of HBase stuff can just be done with its APIs. Hadoop, by the way, came out of a proprietary product at Google called MapReduce and another one called the Google File System. Google published papers on what they did, and a team got together and said, let's build an open source implementation of this. And likewise, Google created a database, a wide column store database internally called Bigtable, and they published a paper on it, and a team got together and said, let's do an open source implementation of that. And that's how HBase came about. Okay, all of the databases in this category are really derived or motivated by what Google did with Bigtable. And notice again, Bigtable comes from Google. HBase, it's open source, but it came from a team that was at that time at Yahoo. Cassandra is another important database in this category, and that mostly came out of Facebook. And so again, a lot of these databases come from big internet companies. Here in this category, you're going to do some schema declaration. It's not as loosey-goosey as key value. But what's interesting is you can declare what we might call super columns. The vocabulary varies depending on which specific product you're using, but you can declare a super column, sort of a category of columns, and then the individual columns in that super column from row to row can vary. And I will show you that, I think, is it the next slide? No, it's the slide after next. More logos, there's HBase, there's Cassandra. The big company behind Cassandra, by the way, is a company called DataStax. So this is the weird thing about all these open source databases is they're open source and everything is free love and lots of contributors from everywhere. But it turns out most of them tend to have corporate benefactors. So DataStax would be that benefactor for Cassandra. Okay, same data. And this is a thing, right? We get a slide template that's widescreen 16 by 9, right? And then they give us a 4 by 3 projector. So by the time you guys get to see the text on here, it is so darn small. All right, look at what I did here. I have a super column called name, and it happens to have columns in it called first name and last name. Likewise, I've got building number and street underneath address. And again, I'm a little embarrassed because I made it exactly the same down here. But again, imagine middle name occurs here. In fact, my demo is gonna sort of bring that to life. And imagine that we had an address here that was in a different country, so we had a different format. Maybe a province instead of a state. Not that there's actually a state in there, but you know what I'm saying. Or maybe there's a county. You get the idea, right? It's that the minutia of the structure will vary. The generality of the structure will remain consistent. And we need a database that doesn't freak out when that happens. Okay? So now I'm being self-effacing, I suppose. That's okay. Let's see. All right, now the demo. Wow, that was unnecessarily loud. Let's see. All right, so what I'm going to do is I'm going to flip over to a virtual machine running my favorite operating system, Linux. And this is actually a virtual machine image in VMware provided by Cloudera, which is probably the leading provider for Hadoop distributions, and they have a VM image that has their entire Hadoop distribution, including HBase, because HBase is included with almost every Hadoop distribution. The one current exception to that would be Microsoft's Hadoop distribution. But it includes HBase. So HBase is there, and I have already gone in through their browser-based shell and gone to this lovely UI for HBase. That was a joke. And so what we're going to do is right-click and copy, and I'm going to create a table. I don't know how well you can read that or not read that. It says create customers, comma name, comma address, comma demographic. So it's a table called customers, and it's going to have, in effect, super columns called name, address, and demographic. OK. And 0 rows in 1.5210 seconds means it worked. So now I'm going to do some more stuff. I'm going to use the put command to put some data, in effect, create a row and put some data in it. So I'm creating a row, and modestly, the key for that row will be my last name, Brust. And I'm saying within the name column family, I want to create a column called first name, and the value for that should be Andrew. And now what I'm going to do is take care of my middle name and my last name the same way. Probably don't need as much narration as I do that, so I'm just going to click around and cut, copy, paste here. Bear with me. Here comes my last name, and good. So now that's there. Now what I want to do is read the data that I created. The first thing I'm going to do is say, you know what, just show me this is like saying select first name from customers where ID equals Brust. That's the SQL thinking person's translation, and it should come back and say Andrew, and it does. Eventually, it says value equals Andrew, and it tells me that this is the first name cell in the column called name. I told you the vocabulary keeps changing. So what if I say, you know what, I don't want first name or middle name, just tell me the name, whatever that means. So I'll paste that in here, and it gives me back all three values. Okay, so you can sort of be vague and get back actually kind of precise answers, which is neat. So I get back Andrew, Brust, and Jeffrey, and then in case, I don't know, anyone's ever seen Gilligan's Island, we'll create one more name here, which is going to be Thurston Howell III. And Jim Backus, played by Jim Backus, who also was the voice of Mr. Magoo, if you didn't know that. And hold on. Does the completely useless trivia make watching me cut and paste go any better? Don't know. Sure, thanks. All right, so we've created that second row, and now I'm going to say, all right, just show me the first name, same way I did it before. OK, that sort of worked. If I can scroll, yep, there's Thurston. And now I'm going to say, give me the whole row. And it gives me all three sort of name components there. Notice it doesn't tell me anything about, what was it, address and demographic. And that's kind of because that doesn't really exist. I didn't create anything in this row for that yet, so it's really not there. It's not that it's there and it's null. It's that it's not really there at all. So now what I want to do, even though these two rows have different schema, I want to see what happens if I do the equivalent of a select star. And in the world of HBase, that's called scan. So I'm going to say scan customers. And what happens? It gives me everything. It does some weird word wrapping there, but Andrew, Brust, Jeffrey is first name, last name, middle name. And then Thurston Howell III is last name, first name, last name, and suffix. No problem. It just can't put it into a nice little grid for me like another database might, but that's all right. So again, think of some, sorry for the echo there, think of some scenarios where that might work, where you want schema to be loose. Go ahead, question. I did set my super columns. Oh. Does anyone know? I actually don't know the answer to that. Can I add another super column afterwards? Yeah, no, I'm really not sure it's a good question. I'm going to find out. You give me your card so I can email you back an answer. All right, that's the end of my little demo on HBase. Oh, except that I want to drop the table so that the next time I do this demo, it doesn't bomb. Before I can drop the table, I have to disable the table, whatever that means. And then I can drop the table. And everybody's happy, I hope. Good. Let's close down that VM. And let's go back to the slides. All right, next category. We're 2 down, 2 to go. 20 minutes. Next category is document stores. And the font gets real small. Document stores. A document isn't really a document. It's a JavaScript object. These databases are all about storing data in JSON or JSON, depending on your level of formality, in that format. And guess who these databases are really, really popular with? Developers. Developers. I won't do that. I won't. No matter how much they don't pay me, I won't. OK, so actually, I could kind of extrapolate and say NoSQL databases in general are popular with developers. And there is kind of, I mean, I'm sure you're aware, there's politics between developers and database administrators. And schema sometimes ends up being the real, the substance of those politics, because developers need schema changes and they prefer to make that happen on an ad hoc basis, and database administrators would prefer that to happen on a very kind of formalized, centralized basis. And there's decent arguments for both. But if you've got a database where schema is not necessary to be declared, then developers can go to town. If you're a startup company and your business model needs to pivot quickly, or you won't get your next round of funding, guess what? Your database requirements are probably going to change with some frequency as well. Having a database that can deal with that is probably a good thing. And it's no coincidence, I believe, that NoSQL databases are almost the default in a lot of startup companies. Part of it is also cultural. I think a lot of developers who work at startups, and I'm painting with broad brushes. I mean, there's no such thing as a startup generically. But a lot of developers in the startup world are going to prefer to work with NoSQL databases. A lot of NoSQL databases are from companies that are funded by the same venture capitalists that are funding the other startup companies. So, this is reality. Things are not always decided on the technical merits, right? Let's not be naive, there are other factors. But document stores are really popular with developers. The native language for the 2 biggest document store databases, CouchDB and MongoDB, is JavaScript. So you write code in JavaScript. You store data in JavaScript format. If we think about what object relational mapping tools do, ORM tools, they're kind of a pain in the neck. What if you didn't need one? What if the objects and the data kind of were in the same format? What if the things you took out of the database were the same things you were manipulating in code? That has a great aesthetic appeal, I would say. And again, go back to DBase. I keep taking it back to DBase today. But that was a language that revolved around the data. It was a database and a language together. And actually, when you deployed a database, you deployed an application. And guess what? CouchDB supports the same notion, because you can actually write so-called view functions or design documents in CouchDB that intersperse HTML and data and actually return back whole web pages. And therefore, you can embed an entire app, they're called Couch apps, in the database. Like I said, these are repeating themes from, almost 30 years ago. Cloudin and Couchbase are derivatives of CouchDB. Cloudin was the company where the guy backed out 4 days before my conference that gave rise to this talk. Perhaps I should thank him. See, the model's better than you think. Couchbase uses CouchDB underneath, but it's sort of its own NoSQL database. And at first, it was just a key value store. even though it's based on a document store. Now it exposes the document store functionality. That's why I put Couchbase up there for both of those two categories. We've already spoken to these points, so I'll keep going. And what I'm trying to show you on this slide is that we're mostly doing the same thing we did with the key value stores. In fact, some people look at document stores as a specialized case of key value stores. But notice that I can have a referential integrity of sorts, right? My most recent is actually a pointer to an object in another database. And notice for address, the value of address is itself a child object. And I'll actually, I hope there's time. Yeah, there's 15 minutes. Let's see if I can show that to you more concretely. All right, let's look at MongoDB first. If there's time, I'll also show you a couple of things in CouchDB. I have another lovely UI for MongoDB. Actually, there is something that can be a little bit more attractive than that, and I meant to bring it up. So I have this third-party application called MongoView that actually is a Windows application and actually is a GUI. And there it is, and I'll connect, and I'll come back to that later. But let's go to my cheat sheet, and I'll just show you a few commands here. Show DBs shows me the 3 databases that I have on this server. By the way, I'm just running this. I ran MongoDB in another command window, mongod.exe. That's how I ran it. You can also run it as a service, but I'm running it kind of as a local app. I want to use a database called test, so I will say use test, and it says switch to db test. And I can say, tell me what database I'm in with the command db, and it says you're in database test. And then I say, show me the collections in that database. Collections are kind of sort of like tables. And it says you've got one called test, and there's a system one that tells you about your indexes. Now what I want to do is create a collection and put some data in it. So I'm going to say everything is db dot. So db dot ships, that'll be the name of the collection, dot insert, and I give it, in effect, a list of key and value pairs in JavaScript object notation format. So name is USS Defiant, operator Starfleet, type escort, class Defiant. Oh, by the way, I didn't write this code. Credit where credit is due. I guess he's a Trekkie, Thomas Jaspers, at this particular URL. So this is his sample, edited by me. Let's add another object to that collection. Objects collection sounds a lot like I'm writing code. And I kind of am, because over here, I can save this object to a variable, j, and then I can insert j. And if you're keeping count, I should have 3 objects in the collection now. And what I can do is say dbships.find.pretty, which will pretty print the JavaScript object notation stuff. And I see the 3 rows of data in my database. Sure looks like I'm just dumping an array of objects, because I kind of am. What else can we do? Here's something that's a little bit more data-ish. I'm going to say, in effect, select from ships, select name from ships where class is greater than or equal to P. And that's what I got back. And I could even, just to really get extreme here, I can even use regular expressions. So there I'm selecting that data based on this regular expression. There's an update method for updating. This will ostensibly change the name of the ship from USS Prometheus to USS something. Although unfortunately, if you use that syntax, it actually wipes out all the other keys. Oops, hold on. See, we only have 1 key now besides the ID. So let's fix that. And this time we'll use the set operator. The set operator is sort of a non-destructive update. So now we're saying operator is Starfleet, class is Prometheus, and this time if we do a find with a pretty print, we should have all of our columns back, and you kind of get the idea. We could then update the name back to USS Prometheus, and then maybe we just go ahead and drop that whole row with the remove function. You get the idea, good. And at this point, we should just have 2 objects left, and we do, and maybe I'll now just drop the whole table. Done. Okay, more, just to show you how this is code, okay? I'm putting a for loop into my database shell. Okay, we're going to create 22 objects where x is equal to 4 and j is equal to, some value between 1 and 22. And if I say find everything in that collection, which I called things, I should see 22. But I don't. I see 20 because Mongo pages stuff by default, and the default page size is 20. So there's this really intuitive command of typing it, which apparently is short for iterate, for more. And then you get the last 2. I couldn't make this stuff up. Let's see, should I belabor this point? We can do more things with JavaScript code. What I want to do now, though, well, let me drop things. Things is now dropped. Here is some data that I've already created. Okay? Pretend these are each big, long blog posts, even though they only have a few words of text. And we have an author's name and a number of votes that they got. And now what I want to do is use some MapReduce to sum up the number of votes, the total number of votes that each author got. So here's my map function. Remember, the map function turns everything into keys and values, so I'm emitting author as the key and the number of votes from a particular record as a value. So this will change. It's a kbanker 2 and kbanker 3 and kbanker 7 and this author 7 and this author 4. And then what the reduce function is going to do is loop through all the values for a given key, sum them up, and return the author's name and the grand total. So this is sort of interesting. I have an anonymous JavaScript function. This is a database, right? I have an anonymous JavaScript function that I'm storing into a variable called map. And then I have another one that I'm storing into a variable called reduce. And now I can say that I want to, on the posts collection, I want to run a MapReduce operation using map as my map code, reduce as my reduce code, and I want the output to go to a new collection called mr_results. And something went wrong. Hold on. It may be that this didn't really happen. Hold on. Bummer. All right, well, it worked in rehearsal. Hold on. No, yeah, but I did before. Here, let's just confirm that. db.posts.find. See what happens when you make all this snarky comments, and then the demo, oh, look at that. Okay. All right, that's weird. I must have dropped the table when I explicitly meant not to. You know what, though? What database are we using? That would do it. Forgot that guy. I wonder if I have to start over or if I can just do this. Ooh, I think it worked. Okay, so now what I want to do is dump the contents of that output collection. And it worked. There you go. Thank you for, yeah. That was all planned. I wanted to take you through all the drama, and it worked so nicely. So 11 and 12. And those are the right numbers. So now we've done MapReduce. Usually MapReduce is done over, lots and lots of rows rather than, say, 5. But you can extrapolate in your mind, I hope. We're going to go back to the slides now. Oh, let me just show you here that I could drill down on localhost and drill down on MyDB and drill down on collections and drill down on MR results, for example, and double click on it. And then I could look at the data in there. So I have some tools. I don't think they're very mature tools, but I have some tools that are a little bit more mature than the command prompts that I'm showing you. Graph databases, with 6 minutes to go. I wasn't going to demo graph databases for you anyway. Here's the way, and Neo4j is the big one. One day I'll learn how to demo Neo4j. But it works on this idea that we have objects and we have relationships between the objects, and the database is built just to track all those relationships. You can also have properties with values or keys with values, but you also have relationships. You can think of the relationship almost as like a join between two rows in a table if you want to map it back into more familiar database territory for us. This is obviously going to work really well for social media scenarios, right? Where we want to track followers and commenters and all that good stuff. In fact, that's why your network of friends is called your social graph, and this is called a graph database. That collision's not merely coincidental. So those are the 4 categories. I demoed 2 of them for you. Keep in mind that if you're going to do sort of data discovery, these databases aren't the right tool to do it, because we need to do lots of iterative queries. We need our answers back quickly. What we will see, though, is that column store or wide column store databases work very nicely in big data scenarios. And that's because we don't really need indexing or consistency. We do need fast reads, and we get them. Distributed file systems and the parallelism that can come out of those are important. Using commodity hardware, which most NoSQL databases do, is important if we're going to deal with big data. We deal with that by scaling out. And if we're going to scale out economically, it's going to be using commodity hardware, commodity storage. And we don't need to deal with web scale, but we do still need to deal with scaling for processing. So those 2 things match up pretty well. Keep in mind that a lot of NoSQL-like features, this came out of that work I did on that white paper, exist in the Microsoft stack. We talked about how Azure Table Storage is a key value store, that XML columns can give you the same kinds of flexibility that you get with loosely schema databases, that Azure Federation is sharding, that we didn't mention, but I'll mention now, OData, the Open Data Protocol, gives you a JSON-oriented REST API for dealing with data, just like a lot of these databases do. And there is documentation up. Obviously, you'll get these slides. You can click on these links for setting up just about every single one of the major NoSQL databases up on Windows Azure, especially because Azure now can run Linux virtual machines. That tends to be a shortcut to running a lot of these. But Mongo is incredible because there's a company called Mongo Lab that will provision whole Mongo clusters for you and do it on Azure infrastructure if you'd like. You can also install Mongo yourself on an old-fashioned Azure worker role or on an Azure Windows VM or on an Azure Linux VM. So you've got, 4 ways to skin that cat. And then there's more things. The beyond relational features in SQL Server, think about file stream, geospatial. Sparse columns are wide column stores, basically. The difference, though, is you have to declare all of those columns in your schema. But physically, we're doing the same thing, where each row actually physically deals with the storage of potentially different columns. Hierarchy ID can let you do some of the things you would do with a graph database. The Parallel Data Warehouse edition of SQL Server, now in version 2, is in fact a distributed database. I don't know if you know that, but PDW is an appliance that has a bunch of SQL servers inside it. And then it has one in front of all the others that makes it look like a single database. There's also something in PDW now called Polybase that integrates PDW with the Hadoop distributed file system. Here's a list of, I've tried to talk about some of the good parts of NoSQL databases. Here's a list of the downsides, and I think the point here is despite the silly clip art on the upper right-hand corner, that the important takeaway here is that if you can deal with these things, and there are definitely scenarios where you can, then you'll get a lot of benefits. But make sure that the downsides are acceptable. Here's some more ideas. Line of business, I would say stick with relational. Large public consumer-facing sites, NoSQL. Complex data structures, yeah, stay with relational. Again, I think NoSQL is really about simple data, but lots and lots of it. Big data, NoSQL, transactional, back to relational. Content management will work well with NoSQL. I didn't really talk about that, but some of these document stores keep lots and lots of previous versions of the data. So doing rollbacks and also just dealing with the variable schema in content management, that works well too. If you're in an enterprise setup, I know that Mongo is going crazy in the enterprise. I will still stand by this. If you're in an enterprise scenario, relational is the thing that makes sense, at least to me. NoSQL may make lots of sense in the consumer web, especially because your funding venture capitalists may demand it. There's my contact information. We're at the end, right as the stopwatch says 0 minutes. Thank you all very much. Come up if you have questions, and enjoy the rest.